converge to the same place. In this case, we're talking about y. There is sort of this picture is kind of bad. I assume it keeps doing this. So like I was showing this position here at 2, it comes down and back up, and then it goes to 2 again, down and back up and goes to 2 again. Yes, this one is periodic.
Mm-hmm.
Okay, the period is the peak to peak is what I call it, or it could be valley to valley. What's the distance from this peak to this peak in x? You see, it looks like
4.
it's just 4 units, yeah. And then the amplitude, it's the max minus the min divided by 2. So in this case, it's 2 minus a minus 2, because that min is down here at minus 2, all over 2, which ends up being 2. This formula will come in handy later on.
Okay.
All right, so number two is not periodic. You'll see that here when I snip this in. It's not periodic because it doesn't return to the same y value. It has a y value here, but it doesn't. We don't see anything coming back up here as far as we can tell. So this one is a big no. You can say does not return to the same y value.
Okay.
All right, that's not a complete definition, but that's probably good enough for what you're trying to accomplish here. All right, it says for numbers 3 through 5, find the measure of an angle 0 to 360 that is coterminal. Okay, so generally there's 2 options when it comes to coterminal angles. Option 1 is you add 360. Option 2 is you subtract 360.
Okay.
It depends which way you're trying to go. Whether you need the number larger or smaller. This is negative, so for number 3 we need to add 360 degrees, and that gets you to 338 degrees.
Okay.
And is that between 0 and 360? Yes, so we're good on that one. Number 4 is the same deal. Minus 229. We need to add 360. And that gets you to 131 degrees.
Yeah.
That's good. Number 5, though, if you were to add 360, it would just get larger. It's already greater than 360, so you subtract 360, and that gets you down to 15 degrees. And that works because it's between 0 and 360.
Yeah.
You can also do this in radian measure. Like you could ask the same question in with radians, but it doesn't look like that's here. So I'm not going to cover that unless you tell me to.
Okay.
All right, so the next grouping of questions 6 through 8 here, it says, write each measure in radians. Okay, express your answer in terms of pi and also as a decimal. Okay, so the conversion from degree to radian is the following. You multiply by pi divided by 180. Multiply by pi. So for number 6, you take this minus 225 and you multiply by pi over 180. Are you allowed to use a calculator on this? I know you need to for this part, but do you generally, were you given a calculator on this?
He made it so there's one part we do and one we, like, it's 2 separate parts, but I feel like this probably.
Well, the second part would be this negative 225 over 180. So they're both divisible by 45, which I don't know if you could get there, but you could maybe see 5 goes into both, but 45 goes into both. Okay, and the top one it goes in 9 times, and the bottom one it goes in 4 times. So that ends up being the reduced form of that.
Okay.
And then you can put that in your calculator and get a number. That's not really all that important for us because I know you know how to use a calculator. For this next one here, it's 120 degrees, and you multiply by pi over 180. So again, you take the part without the pi and you put those together. You should see here, okay, these cancel. And then like 6 goes into both those numbers. That's 2 over 3. So this becomes 2/3 pi. Oh, and you probably should write radians here. Radians here.
Oh, okay.
Number 8 is 600 degrees. So you multiply by pi over 180. 600 divided by 180. Really, we're just testing, can you reduce fractions? So the zeros cancel. 6 goes into both of these, 10 and 3, so it equals 10/3 pi.
Got it.
All right, next grouping of questions, 9 through 11. 9 through 11, you're going the other way, okay? So you're converting from radians to degrees. So if you're in degrees and you're going to radians, which is what we just did, you multiply by pi over 180. To go the other way, you multiply by 180 over pi.
Yeah.
So for number 9, you take this 5 pi over 6 and you multiply by 180 over pi. Now, a lot of things happen here in terms of cancellations. The pi's cancel. 180 goes into 60 30 times. So you're really left with 5 times 30, which is 150 degrees. That one worked out pretty nicely.
Yeah.
Okay, so the next one here, 10. 10 is minus 2.5 pi. I'm going to convert that to a fraction, so it's minus 5/2 pi. And we're going to multiply by 180 over pi. Now, even though I kind of put the pi next to this fraction bar, it's really in the numerator. It's really pi over 1. Pi's cancel. Okay. 180 divided by 2 is 90. So this is really minus 5 times 90, minus 450 degrees.
Okay.
All right.
Do we
now
keep it that, or do we?
Yes, this is exactly how I keep it. Now 11 is kind of interesting because it's 0.8 radians. And if you understand what we're doing, you're like, well, I'm just going to do the same thing I've always done. I'm going to multiply by 180 over pi. So this time, though, there's no pi to cancel. And that's okay. Like the pi's don't always cancel. They usually do, but not always. Okay. So now 0.8 is really 4/5 times 180 over pi. So 5 goes into 180. It goes in 36 times. Okay. And then 4 times 36 is 144 over pi. And this is in degrees. It's weird because it's got a pi, but that's okay.
Okay.
That's okay. All right, we're up to number 12. We're actually moving pretty fast, which is
they're really like
maybe they will become longer. I haven't looked ahead yet. Okay, using the graph below, determine how many cycles the sine function has the interval from 0 to 2 pi. So what that means is you only care about, and actually I can do this because I have the snipping tool. We actually only care about this window. Let me paste that over here. We actually only care about this part of the graph. And a cycle means that it goes from where it starts to where it finishes. Like it goes all the way up and all the way down. That's a cycle. So like this is a cycle here, and then another cycle is over here. So they don't show this, but on 4 pi it actually does 2 cycles. But in 2 pi, it only does, because this is 2 pi here, it actually only does 1 cycle. Yeah. So a cycle means to get back where you started, meaning like if you started, like you could think of like I started here and I come back down and come back up. It depends on that. It's not a great question because you'd like to see something where you have more than one cycle.
Yeah.
Okay, so let's move on to 13. Find the amplitude and period of each function, then sketch one cycle of the graph. I guess you're gonna have to do this by hand. Is that?
Oh wait, we didn't for number 12. We still have to find the amplitude.
Oh, you're right. You're right. My apologies. Yeah. Okay. So the amplitude. We're actually gonna do the period first. The period is 2 pi over b. Okay. And you might be thinking, well, why are you giving me that? Well, we're going to use that in the next couple of problems, but that's a good thing to remember. The period is the number of cycles, is the length of a cycle. The period is equal to the length of a cycle. So we just said the length of a cycle is 2 pi. So the period in this problem is 2 pi. It takes 2 pi to get back where you started.
Okay.
Okay, so now the next thing it asks for here is amplitude. So the amplitude has a formula. You'll find the formula is more useful, especially as you have more complicated problems. It's the max minus the min over 2. So your max, what's the max value this thing takes on? 2 minus what's the minimum value it takes on? Minus 2. Yeah, over 2, and ends up equaling 2 again. Okay. The last thing it asks for is the midline. The midline has a formula that's very similar to the amplitude. It's very easy to mix them up. It's max plus the min divided by 2. So this time it's 2 plus -2 divided by 2. This becomes 0 over 2, which equals 0. Well, let's look at what that actually means. It's the center line. I don't like the word midline, but I like center line. I think center line's a little clearer. It's the one that divides the top half from the bottom half.
Oh, okay.
All right, 13. So sketching graphs, we actually could spend an entire lesson on just sketching graphs. With how things have been, more online, a lot of students are just going to Desmos. You probably don't have that option, but I'll do my best to try to give you the short of it here today. So this one wants you to find the amplitude and period for each function. So for number 13, it's y equals 4 sine 2x. The amplitude is the absolute value of a. Well, what is a? This has this form, a sine bx. So in your problem, it's the absolute value of 4, which is 4.
Okay.
The period is 2 pi over b. Well, what is b? B in your problem is 2. So it's 2 pi over 2, which is pi. So to graph one cycle or one period, you have to know what a sine wave looks like before you even make any of these changes. So do you know what a sine looks like?
Yeah.
Okay, so it starts at 0, goes up, comes down, comes back up. Okay. Now this place right here is one period. So in your problem, this is pi.
Okay.
So where is halfway between 0 and pi? Pi over 2.
Oh, okay.
This is pi over 4, and then this is 3 pi over 4. And usually your instructor wants to see you graph that much. Now, what does this 4 do out in front? Do you remember from class?
That's like how far it goes up.
It's a vertical stretch, yes. So instead of this point being at 1, it's now at 4. Instead of this point being at -1, it's now at -4. So it just pulls it up here. So it looks like this dotted line here. Let me grab another color to just make make that clear. So this is what the modified one looks like.
Okay.
Again, there's a lot that goes into graphing. I mean, I'm really shortcutting a lot of this that we could spend hours on, but we won't. Okay, so the amplitude for this problem is the absolute value of 2. It's the absolute value of the number in front, so it's 2. That's the stretch. That's the amount that you're going to pull it up or down. The period, which usually you just use P for period, is 2 pi over B. B in this case is the number in front of X. B is the number in front of X, which is 4. So that's pi over 2. So when you draw your sine wave, notice I haven't labeled the axis horizontally. This is now pi over 2. And then halfway between it is whatever is halfway between 0 and pi over 2. That's pi over 4. Halfway between 0 and pi over 4 is pi over 8. And then this is 3 pi over 8. This 2, though, what does it do? It pulls this graph up. So instead of it being at 0, 1, I'm sorry, instead of being a 1 here, it pulls it up to 2. So it pulls it up, 0 stays there. This pulls it down like that. There's so many things that the instructor could do here, so it's I don't know what to tell you other than to well, so like 17 through 24 is pretty, I mean, there's a lot going on there. There's a lot of things. We'll see what we can do. Are you in a Algebra 2 class or Trig class?
It's Algebra 2 Trig.
Okay. All right. All right. Do you have that Trig cheat sheet that I sent you a link to at some point, maybe?
Yeah, I have it pulled up.
Okay. So if you look on your unit circle, number 15 is saying, sorry, change that back to black. 15 is saying, where on the unit circle, cosine is the x value. Where on the unit circle is the x value 1/2? There's 2 places in the unit circle.
Oh, 60 degrees.
So we're going to use radians, pi over 3, and
5 pi over 3.
5 pi over 3. Okay. So that's the answer to part B.
Okay.
Okay, so there's nothing there. Now 16 is more difficult, okay? 16 is 3 tangent. There's like so many extra things in this one that's it's more difficult, but we'll talk about this. So first thing is you're going to make a u, what's called a u substitution, because you never work with 2 times a number inside here. So your u in this case is 2t. So 3 tangent u equals square root 3. And then you're going to divide both sides by 3. So tangent of u equals the square root of 3 over 3. All right. Now there are 2 places on the unit circle where the tangent equals the square root of 3 over 3. But let's remind you that tangent is sine over cosine, which is the y over the x. So the way this happens is when you get the square root of 3 over 2 over, I'm sorry, this only occurs when you get 1/2 over the square root of 3 over 2.
Oh, okay. So I have to find the y. So the x coordinate is root 3 over 2. And
Yes.
then the y is, okay. So that's
but
pi over 6.
Okay, so that's at pi over 6, but there's one more place, okay? Because tangent is also positive in the third quadrant, and that's because this can also be negative 1/2 over negative square root 3 over 2.
Oh, so it's 4 pi over 3.
Okay, so our two options are that u could equal pi over 6, or u could equal
Oh wait, no, it's 7 pi over 6.
7 pi over 6. Yeah, I was about to say it's not the same. Now, is our original question in terms of u, or is it in terms of another variable?
Something else, I think. 2t, so I don't know.
It's in terms of 2t, yeah. 2t equals pi over 6. 2t equals 7 pi over 6. So this is called the back substitution step. So then you solve for t. Okay, so do you see how to solve for t? Here you just divide both sides by 2. So t is equal to pi over 6 divided by 2, which is pi over 12. And this is divided by 2 divided by 2. This is t equals 7 pi over 6 divided by 2, which is 7 pi over 12.
Okay.
I really hope that whatever you get on the test is really similar, because there's, again, a bunch of different questions that could be asked for each of these questions. Okay, I'm going to do 27 through 30 next, because we can get them pretty quickly, and then we'll spend time on graphing.
Okay.
You have your unit circle. I mean, it's almost like a cheat, because you just have these answers just are there. So for 27, this is what I guess I don't know. Do you think you'll have the unit circle?
I don't think so.
Okay, so then you have to at least know the first quadrant of the unit circle. And the first quadrant is something like this. And there's 3 places generally. There's 30, 45, and 60. And you have to know each of these values. So right here, it's square root 3 over 2 comma 1/2. This one is square root of 2 over 2 comma square root of 2 over 2. And this last one is 1/2 comma square root of 3 over 2. So you got to at least know these points here. This is the y value at 30. Okay, so the y value at 30 is 1/2.
Yeah.
Okay. All right, so now let's move to 28. 28 asks for the sine of minus 330. Do you remember earlier how we talked about coterminal angles? So we're going to find the coterminal angle. We're going to add 360 to this, because what this is saying is minus 330 is somewhere here. It's the same as adding 360. So this becomes the sine of 30, which we just found is 1/2. Okay. Yeah. So now we're going to do 30. We'll come back to 29. The tangent of minus 60, we're going to do the same thing. We're going to add 360 to it. Add 360. So this becomes the tangent of 300 degrees. Well, where is 300 degrees? This is where it gets a little bit.
Quadrant.
Yeah, 0, 90, 180, 270. So it's down here, okay? And the thing is there's a reference angle that's made with the x-axis. Do you know the reference angle here?
60.
60. So this is equal to plus or minus the tangent of 60. And the way we decide plus or minus is it has to do with which quadrant you're in. Some instructors give you this reference, they say all students take calculus. And in the fourth quadrant, which is where you're at,
cosine is positive.
Cosine is positive, but tangent is negative. So this becomes negative tangent of 60. And that's why it goes back to, do you know your first quadrant values? Because this is sine 60 over cosine 60. Sine 60 is, what is sine 60? Square root 3 over 2. Cosine 60 is 1/2. So this becomes negative square root of 3. But there's a lot that went into that.
Yeah. Okay.
All right. The 29 seems out of scope, meaning like it seems like one that isn't really reasonable for you to be asked to do, because it's like it's an oddity. So let me just grab it here. 29 says the secant of 270. All right, so this is like 1 over the cosine of 270. That's the relationship. 270 degrees on the unit circle is where? So here's 0, here's 90, 180, 270. What's the XY coordinate there at this point, right there?
It would be 0, -1.
Right, and which is cosine? Is it the X or the Y value?
X.
Okay, so the X value here is 0, so this is 1 over 0.
So it's undefined or something?
It's undefined, exactly.
Okay, now we go back to 17.
Yep, a bunch of graphing here, and I'm going to try to do these in an order that's like there's a you kind of want to do these in a certain way where it's like, okay, we're gonna do a sine, or we're gonna do all the cosines, then we'll do all the, maybe all the tangents or something. Although I guess you don't get a bunch of these. All right, I mean, they're not super in detail. I mean, I know you're just kind of getting started with these, but there's a lot that you have to do in each of these before you graph them. But some of them is some of it is simplified here because they're not giving you all the variations on it. So for example, here, like one of the first things you find is the period. The period is 2 pi over b. B is the number in front of x. That's 2 pi over 1. Okay.
Okay.
Then you would find the amplitude. The amplitude is the absolute value of 2, which is 2. So this is a cosine that is just pulled up 2. So like a cosine starts high, goes low, and then comes back up. Okay, so this 2, all it does is it stretches out certain points. It stretches out this first point up here. The 0 stays 0. This one comes down to -2. This one comes back up to 2. So it hits some of the same points and looks like that.
Okay.
And again, you could verify this in Desmos. So if you get access to Desmos on the exam, like you definitely want to
use it,
and you want to compare your graph to it. So all right, so let's move on here. So 18. This is why I'm actually, yeah, I guess we'll do this. So this one, it's kind of like when we graph quadratics, like there's left shifts, there's right shifts, there's up, down, there's stretches. This one just has what's called a phase shift. A phase shift is a left or a right shift.
Yeah.
Okay. And it's going, and the way this is read, it's pi left. Okay. And maybe that isn't clear, but it will be after we draw out what a cosine is. So a cosine, again, starts high, goes low, comes back up, and that's 2 pi. And then it does the same thing, comes down, comes back up, and that's 4 pi.
Mm-hmm.
Pi left means like here is pi, here is 3 pi. Everything is going to go left pi. So this one's at 0. It's going to go left to minus pi. So let me grab a different color to do this. So this point is here. This point goes to there. This point goes there. So it shifts. Everything goes left like that. So this first wave is left here. This next wave is, again, it's left there. When you overlay the two, sometimes it's really unclear.
It's like the opposite.
Yeah. All right. I just need like a 30-second break. I'll be right back.
Okay.
All right, I'm back, and we're going to work on number, whatever the next one is, and it's another cosine. So this should be, there'll be some continuity here of understanding.
Okay.
19. So this is y equals minus cosine theta. Now theta is really x. This is theta over pi. I'm going to just rewrite this in a way that's maybe a little bit easier. It's 1 over pi times x. So I just made theta into x, and I just made this over pi, 1 over pi. The reason is because to find the period is 2 pi over b. B in this case is 1 over pi. So this is 2 pi over 1 over pi. Is this really right? I guess it is. I mean, this is weird. I mean, this isn't usually the way it's done. So this becomes 2 pi squared is your period.
How does that graph?
Well, you've got to change the way you think about this. Like you're used to like wanting these lines to be a certain thing. I'm going to just again draw a cosine. So here's my cosine wave. And I am choosing this to be 2 pi squared. And I just chose that. So midway through, the midpoint here, well, that's pi squared because that's half of that.
Yeah.
And then this is 1/2 pi squared. And then this is 3/2 pi squared. So it's weird, but that's what it is. What does the negative in front do? Like if it was x squared, what does negative x squared do? Because the same rules apply. It flips it over which axis?
The x one?
The x-axis. So instead of it being up here, it comes down here. So this comes up. This point, instead of being down here, comes up. So looks like that.
Oh,
Where it
okay.
flips it. So this is a flip over the x-axis.
Okay.
All right. So the next one we're going to do here is secant, because secant is related to cosine, which is 22. All of these could be graphed on Desmos, and if you don't have a theta button on there, you just type in x instead if you were to get that on a test. All right. So the way that you graph secant is you actually graph a cosine. So this is like graphing y equals cosine x plus 1, and then we make some changes to it. So let's look at a cosine again. So cosine starts high, goes low, like that. With secant and cosecant, you end up having to graph a few more periods of this thing.
Okay.
All right. And we actually need to go a little further, but we'll just go like that. Okay. Now, what does the plus 1 do? The plus 1 shifts this thing up 1 unit. So everything is going to go up 1 unit. So I'm going to use blue here. So this is here, this point comes here, this point comes here. See how everything just moves up 1 unit?
Yeah.
So it's the same thing, it just goes up 1 unit here. All right. Now, we're not graphing cosine though, we're graphing secant, but this is the graph of what a cosine does. And I think I messed this up. Sorry, we didn't actually need to do that blue thing. Let me ignore that. Okay, so the next thing you do here is I'm sorry, this will be a little bit confusing. Actually, we shouldn't have done that. So now, where does cosine hit the x-axis? It hits the x-axis here, 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 and here at these blue places, because this is really 1 over cosine of x, and we know that there you end up dividing by 0. So there's these vertical asymptotes that occur. So the secant graph would actually look like this. It actually touches here, and it's this U-shaped thing. You've probably seen this before. But now you have to account for this plus 1. So this plus 1 moves everything up 1, but you do it after you've drawn the secant. So this point goes up to here. This one goes up to here. So this graph becomes something like this. This one looks something like this. This one looks something like this.
Okay.
I'm sorry if it's not clear. We're really rushing through stuff that shouldn't be rushed, but that is the
it makes sense. You just
okay.
Move it a little.
Let's do 23.
Okay.
Because it's somewhat related to what we just did. All right, so y equals cosecant x over 2. I know it's this theta, but it's x over 2. Because there's a number in front of x, the period is equal to 2 pi over b, which is 2 pi over 1/2, which equals 4 pi. The reason we need that is because we need to actually graph the sine of x over 2. So the sine of x over 2, sine starts at 0, goes up, down, comes back up. With cosecant and secant, you have to draw more than 1 period. So it comes back up. Okay. Now the issue is like, well, where's this 4 pi? This 4 pi is out at 1 period. So that's 4 pi. And this is out at 8 pi. And then this is at 6 pi, and this is at 2 pi. Yeah. Well, the reason we care about this is because this original function is really 1 over the sine. That means wherever it's 0, wherever sine is 0, you've got a vertical asymptote. You got one there, you got one there, you got one there, and so on. These go on forever. And then what you're supposed to do is do this kind of U-shaped graph in there. And so that is complete. Now, the reason we moved it up one in the previous one is because there was a +1 out here, but we don't have that in this problem. So we just graph it as is.
Are those parabolas or are they?
Not really, but they look a lot like them.
Yeah.
If you draw exactly what's here, you get 90% of the points, maybe all the points, depending on your instructor.
Yeah. I don't think he's that picky.
Okay. Okay, we still have 20 and 21 to do, and then 24. So 20, I guess we'll do 20 next. 20 is y equals tangent 5/3 x. Okay, now before we do that, if you don't have Desmos open, you'll want to open Desmos, and I want to make sure you know what the parent function of a tangent looks like, because it's very easy to get it not correctly identified. So the parent function of,
don't they look like little cubics?
They do, except they're bound between these vertical asymptotes. So the width of one of these is pi, which happens to be the period.
Okay.
So whatever we find the period to be of this, because the period of this is 2 pi over 5/3, which means you have to multiply top and bottom by 3/5, which means you get 6 pi over 5 as your period. That's going to be the width of your tangent. So like you probably know that this over here is pi over 2 and this is minus pi over 2. You have to figure out what half of this is. So half of this is 3 pi over 2. So 1/2 of 6 pi over 5 is 3 pi over 5. And that's your width here. That's 3 pi over 5. And then over here, it's minus 3 pi over 5. And then it just looks like that.
Yeah.
If you had to draw another one over here, which I don't know if you would have to figure out what the what 3 pi over 5 is plus 6 pi over 5 ends up being 9 pi over 5, and you get the exact same thing.
Okay.
In there. 21 is a parent function. You just need to look that up and know it. I don't even know why it's here. But it is. Okay, so we'll do 24 cosecant. I was hoping not to do this because this one's really weird. It's like way out of scope for your class. You give this to a trig student, they still would be very uncomfortable with this. Okay, this is really like 1 over the sine of x plus 1. So we need to graph sine of x plus 1. Well, we know what sine is. Sine is, I start here, go high, come down, come back up. Because it's cosecant, we have to graph a couple of periods. So we have to go like that. Okay. Now, this is at 2 pi, this is at 4 pi, and this is at pi, and this is at 3 pi. Okay. But this means this plus 1 inside here, because it's inside, it means we're going left 1.
Oh, okay.
So left 1, well, that's weird, because here's what it ends up being, and this is where you can kind of cheat with how you I mean that in a good way. Like you could just relabel this as pi minus 1. This point becomes 2 pi minus 1. This would be 3 pi minus 1, and this is 4 pi minus 1. You can actually just graph the same thing. The instructor probably won't like that. So what you have to try to figure out is like, okay, if this whole thing is pi, that means this one of these squares is pi over 2. Pi over 2 is, it's a little bit more than 1. So you're not quite you're not quite shifting it a whole square. Like it's like kind of that comes up here and it's going left, but not quite a whole square.
Okay.
Follow like it's something like that.
Yeah.
And then it repeats. But it's the same because it's a 1 over, you're finding the asymptotes. And then you're drawing the U-shaped parabola things in there.
Okay.
All right. Most of these, I'll just make a point. Most of these said to graph from 0 to 2 pi. We went out a little further on some of these, so you maybe would get more credit for doing it that way. But all right. So I think that's everything. I'll send you the notes and the screen recording out shortly. I would definitely study the graphing more than anything else. The rest of the stuff is going to be very similar to what we did today.
Okay.
Thanks for scheduling, and I'll see you next time.
Yeah, thanks. Bye.
Bye now.